welcome to this very brief overview of GUI programming in Java. So far in this class, we've been using command line programs. Here's an example of the printing out the number of times it takes to roll particular values for a four-sided dice. It was homework number 5. So you implemented this. We had to enter in the value. We printed out to the console. We entered in from system in using either text IO or a scanner, and then we print out to the console the results. And so far we've been doing that, and so we've been using the concept of command line or console, yet the console is actually in a GUI, the Eclipse IDE. It's in the graphical interface, or even your command line when you open up CMD or terminal, you're actually running a GUI on your Windows. And Java has built-in graphical user interfaces support for building GUIs. So we're going to start introducing the concept of building your own GUIs in Java. So here's an example of a very simple GUI-based Hello World. We did Hello World way back when, in week 1. So we have to import this Java X Swing J option pane, which is a built-in class in Swing or in Java. And by the name option pane, it's a panel or a frame, basically a dialog box that has a whole bunch of very handy class methods on it. And the one that we're using here is show message dialog. You supply the parent class, which there isn't one, and then the string. And so what that does is it builds this GUI down, you can see it below, is it has a frame, it has the word hello world, the string hello world, it's got an icon and a button, and that's all done just by calling this one show message dialog call. If you click the button, the dialog goes away and we finish the program. So this is a very powerful class that has a whole bunch, I would say probably tens of methods that allow you to show different kinds of dialogues. You can get user input dialogues where they choose things. They have file chooser dialogues. You can print out messages like warning messages, like you chose a negative number when you had to choose a positive number. You can do all sorts of things with this one class, and it is very simple to use. You just use these static methods on it, and it's a very useful class to know. The next concept in GUIs is that GUIs have components in them, or pieces like a button or a label or a panel or some things. And in Java, each of these components is an instance of a class. The most fundamental GUI component is the window. And in the lower right corner you see there is a window. Windows have a frame around them, they have a title bar, and then they have a place to put the content of the window. In Java, the window is represented by the JFrame class. Again, that's in Java X Swing package. The JFrame has a title bar and then the window where you can stick other components to build your GUI. So here's the test code here. I have a JFrame window, I say new JFrame, and I provide the title text. So in this case, GUI test. I commented out to set the content. That would set the contents of the window below the title bar. So I commented out so we don't set it, and you can see that it's a blank content. We can set the size, how many pixels wide and how many pixels high do we want that to be. We set the location on the screen, the entire screen of your computer. And then finally we say set visible to true, and that will cause Java to draw this window on the screen. So we have a bunch of functionality where we can create the window, set its title, set its size, how big we really want it to initially be. Windows or frames, JFrames are resizable, so the user can drag it and resize it. Set the location, where do we want it to appear on the screen itself, the computer screen, and then finally we say set visible to true, so it actually gets rendered onto the screen. The next component, fundamental GUI component that you'll be using a lot of, is the JPanel class. It's also in Java X Swing package. Basically, it represents a blank rectangle. So you can imagine in this GUI in this JFrame, we would put a panel as the content and then build up more content. So it's a blank rectangle. One of the first things we can do with JPanel is we can actually use the paint component method that is supplied. This is overriding the method from the JComponent class that provides the graphics content, and then when we call super paint component, that will fill in the background color for the panel based upon what the background color is, and then we can call methods on this graphics context like draw string, which will draw the string hello world at an X position of 20 and a Y position of 30. So we have the string that we're going to draw on the panel, and then we have our XY position where on the panel we want to actually draw that string. So it's a very powerful, then, and we'll talk later in this screencast about some of the methods that the graphics has, and there are, again, tens of them, and they're very powerful. You could draw your own graphics. The second thing that panels have is they're also containers. So you can think of them as a container that holds other components. So when we construct our JPanel content, we need some way of sort of managing where the things get added to the panel, and that's called a layout manager. And Java has several different layout managers. One of the simplest is a border layout, where you have different areas, like the north, which is across the top of the panel, the west, which is on the left-hand side, the center is in the middle, and east on the right, and south across the bottom. So now we can add different components to the different places in our panel. So example, content add display panel, border layout center is going to put a display panel in the center of the JPanel, and then we add a button to the bottom, and if there's nothing in the west and the east, center goes and fills the whole space. So you're going to have, if this particular one will have a panel that covers the whole top part, and a button in the center of the bottom part of the JPanel. If we then add that to our JFrame and set visible to true, we would see that window be rendered. So how do we interact with GUIs? As we recall way back in the beginning, computers basically have two options for figuring out when things happen. One, they can poll all their components, so the panel could say, hey button, did you press, and move on to all the components. Or we can use an event-driven mechanism that when the button is pressed, an event is generated, and then the program can respond to that event by using event handlers, which are commonly called listeners. So you're listening for these events, and when the event occurs, you actually execute a method that says, I'm going to do something when the event occurs. So the code has an example that we're creating a class, button handler, that implements an action listener, and the action listener interface is saying, I have a method called action performed that takes an action event. So something is going to cause an action event, and when that action event occurs, I'm going to execute system exit, so I'm going to end the program. So this would be on a quit button. If you press the quit button, the action event occurs, this method's called, and the system exits, so the program ends. Now, if you just do this, you're not saying which event source do you want to listen to, so listeners must register with the component that generates the event. So in the example, we have a OK button. We create our button handler by just instantiating a new instance of that class, and then we call the add action listener method on the button. So that's telling the button that when your event is generated, tell listener about it. So call listener's action performed method with the event. Now, buttons and other GUI components can have multiple listeners. So you can have, the OK button could have 3 or 4 different action listeners listening for those events, and eventually if we use the button handler, that one will quit the program. But you can imagine other things where if you press the button, it increments a count, and another one redraws, moves a car on the screen or something. So you can imagine a lot of different behaviors that you could do with just adding different action listeners to the button. So it's a very flexible system where you define the action listener does some behavior based upon when the event occurs, and then you register that action listener with the different GUI components so that it listens for those events. It's a very powerful design pattern for handling or dealing with GUI components. The next thing to think about is everything on the screen is actually drawn by the computer. There's just everything, your IDE is drawn by it, your console, this PowerPoint is drawn on the screen. So the J component is the base class for most of Java GUI components. It defines that paint component method that takes the graphics content. So all the JPanel, JButton, all these guys extend J component. So if we wanted to actually control how the GUI component renders or draws itself, we could override the paint component and take over everything. The one concept is that if we want to control that, we define paint component and it draws the entire GUI component that we have, but we don't want to call paint component because Java's got to paint all the GUIs that are the Java GUIs. So we may have if one thing's over the top of the other, we don't know if we get painted or the other one gets painted. So we don't directly call paint component, we define it for our particular component. If we want to redraw our screen, we use the repaint method, which then queues a request to Java to call paint component when it's ready and has handled all the events and figured out all the right things to do. So when we call repaint, that basically sends an event into a queue that eventually the system will call our paint component at some later time. It's just a little tweak of the idea that we need to implement paint component if we want to control everything about drawing it, but we don't call that method, we ask Java to call it later. And so the idea of coordinates, everything gets painted on or drawn on the screen. The computer screen is basically just a grid of pixels. Now on modern screens, that's a lot of pixels. It's 1280 by 900. That's kind of one of the basic ones. Or one of the big, huge screens have many, many more pixels. And you can set each pixel individually. The upper left-hand corner of your screen is 0, 0. X goes across horizontally, Y goes down vertically. And so if you want to figure out how big your component is, your individual panel that's going to be rendered on the screen, you can ask it, you can call the method getWidth, which will get the width of that individual component. And you can get the height by calling getHeight. So now imagine you had a drawing and the user resized your screen. Well, you don't want the drawing to stay up in the upper left-hand corner or whatever. You want to perhaps stretch the drawing or move the buttons so they all fit in the screen. You can do the math by saying, oh, I want to put this thing in 1/3, 1/3 of the screen, that's the upper corner of it. So I could calculate 1/3 width, 1/3 height, and I could start drawing my rectangle or something there. So using that is a nice way of controlling how to draw your thing. And since you can get the width, you can actually make your GUI component resize in a nice way. Remember, it's always upper left-hand corner is 0, 0, and then X goes horizontally to the right, Y goes vertically to down. So larger Y's is down, larger X is to the right. Java also supports a basic set of colors. Java uses the red, green, blue color system. By setting each individual component of red, green, and blue, we can build our color. The values of red, green, or blue vary from 0 to 255. That's basically 8 bits. And also the Java color class has defined some common colors, not very many. If you need some other ones, you should use the RGB. There's a whole bunch of RGB selectors on the internet that allow you to find the exact RGB values for the color that you're interested in, and then you can construct your color exactly as you want. The color class also supports hue, saturation, and brightness, which is another way of describing colors. It doesn't actually have a constructor that does that because the three parameters would be the same parameters, so you can't have two constructors that have the same parameter types and number of types. So that's why they use this instance method this class method that returns a new color. Basically, that's called a factory method. It builds a new color instance given the hue, saturation, and brightness. The graphics object that we pass into paint component has a current drawing color, so if we want to change the color that's going to be drawn, we call g.setColor and we provided a new color. Components also have a foreground and background color that you can set by saying set foreground and supplying color, or set background and supplying color, and then call repaint, and that will cause the component to be repainted. This Java will call paint component and will render that object, but you could change the foreground, background, and see what the new colors are. So the color system, very simple. Java supplies a color class. You can build new colors using RGB, or you can use hue, saturation, and brightness, and you can then change the graphics object to draw in other different colors. Now, how do we deal with fonts? Well, fonts are the things, the way text looks like on the screen. Java has a font class, and it has a bunch of styles, basically the name. Serif, sans serif, monospace, dialogue are the ones generally supported. There are several others, but it's dependent on the platform that you're running on. Comic Sans may not be on all your platforms, so the set of names that are supported by Java is dependent on what platform you're running on. The style basically determines, is it plain, regular old text? Is it italic? Is it bold? Or is it bold and italic? And then lastly, the size. How big is your text? And the number is generally, sorta, maybe the number of pixels the tallest letter is. Sorta, not always. But 12 font is half the size of 24 font. So you build your fonts by saying new font, you give it the style or the name. The style and font has some static instance variables for plain, bold, italic. And that builds you your font. You can then set the font on your graphics instance and then draw the string, and that will use that font to draw the string. So that's how you can change, have a bigger label and then a smaller label if you change the font. And lastly, we're going to talk about drawing shapes, and this is basically most of the graphics methods that you're going to use to draw things on your panel or your button or whatever. Everything that's got the paint component method, you can take the G and the graphics G and then use these. So draw string draws a string, you supply the string, and then the X and the Y, which is the upper left-hand corner where the string will be drawn, is drawn horizontally. Draw line goes from X1, Y1 to X2, Y2, so we could draw a line anywhere across the screen. Draw a rectangle. The upper left-hand corner is X and Y, and then its width is width, and its height is height. Draw oval will draw an oval inside the rectangle defined by X, Y, width, and height. So if you have a narrow one, you get an oval. If it's a square, you get a circle. Draw a rounded puts a rectangle in the XY position. It's got a width and a height, and then it's got an X diameter and a Y diameter to determine the curve of the corner. So that's a rounded corner rectangle. An arc, again, you draw an arc in the rectangle defined by X, Y, width, and height, and then the start angle 0 degrees is to the right, and how many degrees do you want the angle to, or the arc to be. So you can have arcs. And then there's a bunch of fill methods. Fill rect fills in a rectangle, so the whole rectangle is filled in. The draw rect draws just the outline. Fill oval fills in an oval. Fill round rect fills in a round rect. Fill 3D rect gives you a rectangle that has a 3D effect to it. It looks like it sticks out a little bit because it's got a little bevel around it. And then we have the fill arc, which will fill in an arc. And so those are some of the common methods that you can use and combine together to draw different things. The text has a whole bunch of examples of drawing 100 circles on the screen and then animating them and having them grow or shrink or move. You should take a look at some of those. And so these few methods basically are good enough, if with a lot of effort, to build your GUIs. Later on, we're going to talk about some of the more common classes and components of GUI development, like how to build a button, labels, input text, text areas, those kinds of things. So this is just a brief introduction to building and creating GUIs in Java. Thank you very much.